All right, so you need your standard stuff out plus a calculator. So if you don't have your calculator, you can grab one of my yellow ones up here. They're fancy schmancy yellow because they're a school set. We have new teams. You grabbed a card when you came in. We should have new teams. What are you looking for? What is it? A 9? 9's the right idea.
Oh, I thought these are clubs and not.
No, 9s. Yeah, it doesn't matter. We're going by like what the card type is. Well, not suits, number. But kings, queens, those aren't numbers, but yeah, numbers. What are you looking for? Alright, should be pretty close. If you have 2 groups, it's probably just somebody's absent. I mean, good. First, have your names down. Just have them in the middle of class. A or extensions. Let's talk about that. We should think about it. If you had a check minus on your math journal, thank you for that segue, though. That was good timing for an announcement. If you had a check minus on your math journal in the feedback that I gave you, you need to fix that and turn it back in. If you don't need to talk to me and you think I just did what I was missing or whatever else, you can just stick it back in the turn-in bin. If you need to talk to me, AO or extensions would be the time that you want to take care of that. So if you have a check minus, those are not in math yet, but it's going to go in math eventually. You cannot just turn in the paper. I need to see your entire journal again, because I'm not going to necessarily remember exactly what was up. And I want to see that you're actually fixing those behaviors. So part of the feedback that I wrote down in mine might be they're not numbering. They're not dating. Like, we got to check those things. So we should have this is where you ended off with Mr. Smith yesterday. But before we dive back into that, we got to determine what our group rules are with the new groups. At your table, you have a laminated team roles sheet to remind you so you can refer back to it. If you forget what you're supposed to be doing as that role, you can check back there. If you have the hearts, so check your card. If you have the hearts of that card type, you are the resource manager. If you have the spades, you're facilitator. If you have clubs, you're recorder. And if you have the diamonds, you're the task manager. Now, I think what we're actually going to do to fix this is, Alan, let's have you come up here. And for now, we're going to have you come back to this table, and we are get you the other stool. I got to see if I can steal a chair from Mrs. Gordon. But this is actually probably the most comfortable seat in my room, so that's why I bought this one. But I don't know if you'll be heavy enough to actually get that down. Stools make you more alert, too. If I could, all of you would be on stools. You don't need to lean back. It doesn't help your learning at all. Are we good with who is what? So real quick, check with each other, say what you are for your role, and remind people what your name is. And if you have your name tent, get it out. If not, you need to remake one at some point today, because tomorrow you definitely need our name tents. So I'll go ahead and get those note cards out. If you don't have one, grab it at some point today. Make sure you make a new one. So here's the name tent note card here by the Sharpies. Make sure we all know who's what. Then get your math journal open to yesterday's page. Math journal open to yesterday's page. So, sorry, this is kind of confusing. So, Alan, you're going to be whatever role's left over after their card since you didn't have an ace. So you're the spades role. So you'll be the facilitator. So your role's the facilitator. And then Rod, you're going to be whatever they didn't have. Whatever. Task manager, so you'll be task manager. So with your new group, really quickly, in your math journal, just write down your new group. So our date today is 8:30. Make sure you're dating every entry in your journal. So somewhere you need to have the date 8:30. Our topic today is going to be 115 when we get to it, I believe. All right, now it's the light track though. Yeah, 115. It's all about rewriting. So your new group. Just jot down first names of who's in your new group. It will help you immensely to remember who they are. So if I was Aubrey, I'd be writing down Delaney, Emma, and Monica. So I don't know, maybe Mr. Smith is in my group, Mr. Cabilo, and so it's not all boys. Maybe we also have Mrs. Goldberg. So you had in your journal, hopefully somewhere close, or maybe it's on a previous page and you need to copy it down again. You guys had figured out that 100 meters would take 70,000. Now, I wasn't in here, so can somebody help me on how you guys figured that out? How did you get to there? Did you really stack 70,000 pennies? That'd be impressive. Francesca?
We started by seeing how many pennies was a centimeter, and that was 7.
Oh. So, you started, we really were talking height, so I'm going to abbreviate that HT, and pennies. And you said you first did 1 centimeter was how many? 7. So then, how did you end up, but centimeters to meters, where'd you go next? What is 1 meter? How many centimeters is 1 meter? 100. So to get to 100 centimeters, what would we need to do? Hopefully we're jogging our memory with what we did yesterday. Go ahead, Alice.
We multiply the 7 pennies by 100.
We need to multiply by 100, and we do that on both sides. Guys, if you don't have this in your journal from yesterday, go ahead and jot that in here. Little T-chart, height, pennies, and that 100 centimeters then would equal 700 pennies, which I can rewrite and say, well, that, I'm going to switch back to blue because I'm going to be in meters again, is 1 meter, because these are the same thing. Is 700 pennies. Now, if you look in your book, if you have it out, which is okay if you don't, if you look in your book at your 114 lesson where you guys were at yesterday, one of your classmates thinks, well, 700 pennies is awkward to work with. What if we want to work with 100? Because 700 is weird. Because I want 1 million, right? I want 1 million pennies. That's what we're trying to get. Could I multiply from 700 to 1 million easily? I'd have to do a little bit of work. I could figure out how to do it. Yeah, and I probably need a calculator, and I don't want to use a calculator right now. How could I go from 700 pennies to 100 pennies if I want a reference point to work with? Divide by what? So please put that in your math journal. If I want to go from 700 pennies to 100, we just divide by 7. Now the weird thing then is, though, we're already in meters. So this is going to come out to be a portion and then we will need a calculator, which is okay because we're going to use calculators a bunch today, so you should already have your calculator. So go ahead and in your calculator, do 1 divided by 7, and you should get, and we'll talk about these trends later, you should get 14, 28, 57. But there's a decimal in front of all that. And I could actually tell you any division by 7 because there's a really, really cool pattern that happens, but we'll get to that later. And that's meters still, right? So I'm going to actually scooch. That's meters. So the last thing, the main thing you were trying to get to with yesterday's lesson was getting to 1 million pennies. know what will take me from 100 to 1,000,000? There's a real easy way that you can do this. How many zeros does 100 have? 2. How many zeros does 1,000,000 have? How many more zeros do I need? 4, right? I need 4 more zeros. What happens if I take 100 and I multiply it by 10? What does it turn into? You got a calculator, right? So let's play with this. You get what? 100 times 10. What do you get? 1,000, right? So how many zeros do we now have? 3. Start over. What if I do 100 times 100? How many zeros does that have? 4. 2 from there and 2 from there. What if I do 100 times 1,000? How many zeros does that answer have? 5. 2 from there, 3 from here. How many zeros should be in the number that I'm multiplying by to turn 100 into 1,000,000? Well, I need 6 to finish. I'm starting with 2. How many more do I need to pick up? I need 4 more. So what we multiply by should have 4 zeros in it. So we are multiplying by 10,000, actually. Now, here's the really cool thing about what we're actually doing. Anyone ever do the Cupid Shuffle? Yeah. So I DJ our school dances. You'll learn that once we start to have canteens. Multiplying by powers of 10. Any number that starts with a 1 and it's all zeros then is a power of 10. Does the cha-cha slide. I'm serious. This tells me I need to move. Am I getting bigger or smaller when I multiply like this? Bigger, right? So I want to get this number bigger. This tells me to move my decimal point to the right, to the right, to the right, to the right. However many zeros you have, your cha-cha sliding your decimal that far. Now, if we were dividing, just go the other way. We'd go to the left, to the left, to the left, to the left instead. But because we're multiplying, we get bigger, and my answer comes out to be 1428.57. Put your commas, figure out what your number actually is. 1,428 meters. That is almost a mile. I don't even know how many meters are in a mile. Any swimmers in here do a mile swim? Any Boy Scouts in here? Mile swim is an award, like a patch that you can earn. I got it at camp. 1,600 meters. So if you are at a standard pool, from end to end is 25 meters. So I go down and back is 50. Down and back is 100. Do that 16 times, you swim a mile. This is almost a mile stacked of things. Almost. We're about a football field short. So this is just getting you to understand exactly what Mr. Smith left you with, proportional relationships. There is a relationship between pennies and height that is proportional. The more pennies I have, the taller it is. If I have 0 pennies, how tall is it? 0. All proportional relationships have 2 things that have to happen. If I have 0 of one thing, I gotta have 0 of the other. So if I'm having 0 friends over, and I'm making dinner for myself, and I make 2 hot dogs, that's 1 person, 2 hot dogs. But if I'm talking about friends, 0 friends, 2 hot dogs, that doesn't work. I need the 0, 0. Right? So 0, 0 point, like paint in walls. If I'm painting 0 walls, I need 0 paint. If I'm painting 1 wall, I need a gallon. If I'm painting 2 walls, I need 2 gallons. We'll come back to this idea of proportional relationships. So go ahead and flip in your book to page 21. Do you have anybody feeling like reading today? Anyone got their voice warmed up and turned on? We're on page 21, lesson 115. Patrick, right?
Yeah.
Patrick, go ahead and start with in the past. Hit us with that whole paragraph.
In the past, you may have looked at a number of patterns to answer questions and find the next part of the sequence. Have you ever taken a moment to consider how amazing the mathematics will investigate number patterns and learn about equivalent ways to write the same number. As a team, you will look to justify why two representations are the same and share your reasoning. In this course, you will often be asked to explain your reasons and justify your answer. When you are reasoning and justifying, you will focus on what makes a statement convincing or how you can explain your ideas. As you look at patterns today, ask the team these questions to help guide your conversation. How can we predict about the next number in the pattern? How can we justify your answer?
Yeah, what can we predict about the next number? So, to really get the most out of this lesson, you got to promise me that you won't work ahead. So you as a group are going to work through 1-40. You're going to do the math and pay attention to PEMDAS, make sure that your calculator is doing it right. Multiplication is going to come before addition. So if you look at like 1-40A, we're going to have that multiplication. Why the dot? Why the dot between 1 and 8? Yeah. Oh.
Because x is a variable and it could confuse people to think that it's a variable instead of multiplication.
So we got to stop using x for multiplication. If you are stuck there, please move on into the dot multiplication world with us. X is now our variable. So work through 1-40. Then once you work through that entire thing, then move on to 1-41. And I will give you a time check that if you're still on 140, you should probably start moving on. But remember your new team roles. Everybody should be writing this in their math journal. So if we're going to start a new problem, label it. This is 1-40. I'm going to get more specific with my journal checks as we go. You should really just about have every numbered problem from the chapter in your math journal. Obviously, the homeworks are really important, what I'm really checking for, but if we're doing stuff in class, you should really have that stuff written down. So you're working 140 A through G, and then if you get done with that, go ahead and move on to 141. Cool? Have at it. They were actually a bit smaller. A couple people moved out of there into the accelerator. So they'll still be okay. So you should be writing down the work to support what you're doing. So, and you can number the A, B, C, D or not if you can remember like what we were doing. But we should see your 1 times 8 plus 1, 12 times 8 plus 2, 123 times 8 plus 3. You should have that stuff written down with your answers. To notice these patterns and pick up on these things that we want to see, we got to write it down. So we can't write in the book. trying to get your cards, if you could try to have all up. I'm going to use those next time. Thank you. So you've got one more minute. Try to talk amongst your group. What pattern do you see? And then I wrote up on the board, if we then extend this one more, 1, 2, 3, 4, 5 times 8 plus 5, what would you predict that to be? So talk with each other for about a minute or two, because there's not much conversation going on. I know we're computing. Talk with your group. What do you think that would be? I really wish, and I might try to figure out how to do this, that this could stay there while I scroll. No, because I wanted to do my header would stay. Yeah. Yeah. It'll work. Like a spreadsheet. That's what I really want. So you're using like the graph paper? No, well, I'm using graph paper as just a picture later on. Not even like Smart's graph like thing. I actually just inserted a picture. Because I am now. So let's play the if I get hit by a bus thing. It's just one file that I'm just gonna have continuously lower. So I have like copy. So for today, I just set up that one in 3 pages. Because I mean, if I switch pages more than 3 times, probably reach the end of class. Right. So you still have another blank instead. But then these blank ones just all are ready with a header, and I can just fill in every day. So I've got like accelerated setting, like the roller coaster problem that we're doing. So that's one file for yeah, it's just for every like the whole year. I'm just I might use a new one for like each month, but like it's just regular 17, 18 class notes. So if I ever get hit by this, it'll fall off my house. That's what Terry's afraid of now. I told her I wasn't hooked up the other night because Rain had my rope. Yeah, I get how dangerous it is, but my roof is not very steep, and if I'm not tied in, I won't stand up. Like I just got to scoot the whole thing, and then it's like it's too fall. You're sweaty and like you'd be okay. All right, somebody from. Actually, so the reporter then, from the nines are not queen group. Where's my queens at? All right, somebody, or the reporter actually, from the queens group, tell me what you noticed. What pattern? Who's your reporter? So real loud so we can all hear. What do you think, Matt? What about the results, the answers? What's going on? Yeah, so the first number we're working with started with 1, then it was 12, then it was 123, then 1, 2, 3, 4. So you'll see how the first number we're working with just keeps adding on the next digit. But be careful saying adding on, since adding is a math verb. It is changing by, having or placing a new digit, which is the next one up. What else is changing in the start, like what the math is telling you to do? What about what you're adding by? What do we add by in A? 1. What do we add by in B, Matt? It's right here, the addition after the multiplication. What do we add by in B? Then in C we add, then in D we add. So, if my reporter from my aces, over here, what do you notice about the answers?
Well, it starts with 9, and then it counts down through all of them, so it's 9, then
Then 9876. So what if we try to predict here? I put this 5 on here. If this pattern continued, I put that 5 there and I put that 5 there. What would you predict the answer would be? 98765. Try that in your calculator. The 12,345 times 8 plus 5. Try that real quick. Does this work? This is where I fell in love with math. Literally fell in love. My wife is okay with it. I can have multiple ways. This is where I fell in love with math. Why do you think this is happening? So take a second to kind of debrief this with your group. Then flip on to 141, and we're going to start working with some divisions and try to see some patterns. Please follow the instructions in the book. Do not calculate when it asks you to predict something. Kind of play by their rules. I'll bring you back in maybe 5 more minutes. So try 141 with your group. On 141, if you needed a debrief any more of 140, talk about that, then move on. So if anybody has anything last they want to say about 140, then move on to question 41 and start doing these divisions. When you change problems, make your math journal show that you change problems. Squiggly line something. When we do a new problem, make it obvious. Since we're going to do divisions, write those down, please. The 1 divided by 9, the 2 divided by 9. Write the things you're doing in your math journal. All right, I'll shut up again. By the way, sorry, I have to say one more thing. Do not trust your calculator 100%. You can trust it 99%, but you can't trust it 100%. Sometimes the last number lies to you. We'll talk about it. It's not really a lie, but do not trust the last number. Okay, if you're writing down, because I hear Alan over there saying 2, 2, 2, 2, 2. Be careful with the last number. Okay? And I do the same thing. All right, keep going. I have got queen in my yeah, I take out an entire number. They 19. So one group, so take out a whole suit and then take one out of the other. For that. We'll hope.
No, you don't.
Four rounds down. 5 and above. Yeah, 5 and above. 5 down, 9 up, and 4 down.
About 2 minutes. Bring it back together. What do you think? even if you take it off, it's still just 0.1 anymore. Yeah, so you're fine. Sometimes, like that 8 is a lie. See how that? So, yeah. So you're good. Yep. It's rounding. So the problem is when we're trying to be precise, we don't want to round, and we're looking for patterns. So rounding will mess up our pattern. So yeah, guys, it's not really a lie. I use words loosely a lot of times you'll learn. It's rounded. So if it doesn't need to round, or if it can round down, it won't lie to you. But sometimes if it rounds, it will be the wrong number. About a minute. We'll bring it back. Ooh, the math frac button. Frac deck. All right, this is a good time to talk about the frac deck button, or the deck frac, depending on your calculator. On your calculadora, you have Spanish. You guys got to start learning. You have a button that says table, right here, right next to clear. And above that, it has F arrows D or D arrows F. That's your frac deck or your deck frac button. What that does is convert decimals to fractions or fractions to decimals. So if you type in a division to your calculator like 2/9, and it gives you 2 divided by 9, that's frustrating. I already knew I was doing 2 divided by 9 calculator. Thank you. I need the decimal. You will hit second, then hit that button that says table, because we want the secondary function of it, which is the thing above it. So everybody type in like 2 divided by 9. That was one of the things we typed in. If it gave you a fraction, you want a decimal. Even if it gave you a decimal, follow with me. Hit second, then hit your table button, then hit enter. It will switch it from whatever it is to the other. If it was a fraction, it'll make it a decimal. If it was a decimal, it'll make it a fraction. And you can do that switching back and forth all day long. So, now that we've all typed that in, what did you get from that? You got 0. Well, okay, so that was for 1/9. 1, 1, 1, 1, 1, 1. What do we do when a number repeats forever? How do we represent this? Marvin? Put a little line. So after I read a couple of them, I get tired of writing them. I put a little line above it. That, please, in your math journal, this is called the repetend. Or the little bar. Or the repeating bar. We don't really have to use the proper name, but I like you guys to know them. 2/9. Who can tell me 2/9? Give me 2/9, Eleanor.
0.2 with a line over 2.
Yeah, so 2. We like to show a couple, then put the line. You could just put 0.2 with the bar over it, and that would be accurate. But we like to show a couple of them. It helps our brain too. And 3/9, anybody? Anybody? 3. So, did you calculate 4/9, or have you predicted it? I think calculate. Yeah, you did calculate. What was 4/9? 0.4444444. If you're on the golf course, that will scare people. 4 means like take caution. There's a ball flying at you. So if you said 444, never mind. So. Who can talk? Let's go. Now my cards are back there. Who can talk to me about what predictions you made and why? Because you should not have calculated these before making a prediction. What is your prediction and why? Maybe talk to Patrick, but I'll give him one more, I guess. Patrick.
That there's a pattern going on here.
Okay, what pattern?
So like it's always repeating. So if the number above the 9.
What do you mean? Okay. Okay, so the number above the 9 is what's repeating. From the 2, the 3, the 1, that's happening. It's proving to be true. So you will predict for 5/9, it's going to be 0.555555. When you do it in your calculator, does it work? Yeah. 6/9, what would you predict for that? 0.666666, and it's alright, only if you stop at 3 is it bad. 666 is the sign of the devil for some reason. You can, I forget why. What about 7/9, class? We should have these things written down. 7/9?
0.77.
0.77777, and that's supposedly good for some reason. And 8/9. Okay, so it probably is going to just keep doing the same thing. Question for you. What about 9/9? You sure? But the pattern that we have says we're going to repeat the number on the top. Okay, but so is this pattern true or not? Because if this pattern's true, which it held true for everything, then we would predict that this would be 0.999999 forever. But, and you don't have a name tenant to help me out, Nathan says that this should really equal 1. What is this at the first 0.9? If we say it the proper way, that's really 9/10. The next one, 900ths, 9,000ths, 9/10,000ths. So I have a little visual here. If this pattern is true, it's 0.99999 forever. But we know, well, how do you know that, Nathan? How do you know 9/9 is 1? Okay, so the numerator is the same as the denominator. I have a little visual for you here. So here starts out with your 9/10. Then, if I made 100 little squares in the box, they'd be this size, so that's 9/100ths. So watch what happens. So we have our box. That's our whole, right? That's our 1. The box is 1. We got 9/10. Now we add 900ths. Now we're going to add 9,000ths. Now we're going to add 9/10,000ths. So we got to zoom in a tiny bit. Then 900,000ths. And it would keep going. By the way, the ... in math just means this keeps going. So, what do we think? Is it really? Is it equal? So, ponder that for a minute. Well, we're going to come back to these ideas. Vocabulary that we want to make sure we get down in our math journal. These sort of things, when it goes on forever, is called, or are called, repeating decimals. So please make sure in your notes, somewhere around this, off to the left, right, wherever you decide, you write repeating decimals. Now I'm going to be all fancy, and I'm going to make a little bracket. I'm going to say these are repeating decimals. I should see everybody writing. Goes on forever. Now, if it doesn't repeat, what's it do? If it doesn't repeat, let's say, I'm still on 830, I'm on the 3rd page. If it doesn't, let's say like 1/2 or 1/4. What's a half? Anyone know that decimal? I'll get you out of here real quick. Patrick?
It's a terminating decimal.
It's 0.5. 1/4 would be 0.25. These, if they're not repeating, we call them, please write this down, and then we're going to be good to go. These are terminating decimals. Because to terminate means to stop or end. So it has an end to the decimals. The decimals stop. There's no more. With that, please make sure that you had your homework written down. It was 45 to 49.
Oh,
I will get it up on the homework board. Sorry I wasn't there before you guys came in. And that is our lesson for today. So we will pick up this learning tomorrow and continue onward. If you have a check minus on your notebook, please take care of that AOR extensions. Have a wonderful day, guys.